Guys, in this video I'm going to discuss how you earn bonus by solving this torque bonus problem worksheet. You need to either print from your home computer or you can copy the question and the drawings on a separate sheet of paper and submit that to me by Friday of next week. So we have for question 1, a flywheel consists of a solid cylinder with a small radial axle protruding from its center as shown. You can see that the string is attached around the smaller radius. The following data are available for the flywheel. So we have the mass of the flywheel, which is the larger part, the small axle radius, we have the flywheel radius, and the moment of inertia. This is 1/2 mr squared. Sorry, I don't know why the 2 came down here. 0.5 mr squared. And it asks us for number 1a. An object of mass m is connected to the axle by a light string and allowed to fall vertically from rest, exerting a torque on the flywheel. So this small block is wrapped around this small radius, and as it extends or towards the floor, as it falls towards the floor, it causes this small piece to rotate, which is connected to the larger flywheel, so the whole system starts to rotate. But please note, the string is actually wrapped around the small one. So torque is applied to the small radial axle. The velocity of the falling object is 1.89 meters per second at 3.98 seconds. Calculate the average angular acceleration of the flywheel. So using this information, you can get the average linear velocity, the average linear acceleration would be the change in velocity over time. And we know that the object falls from rest. And then you can relate your average linear acceleration with the angular acceleration. And we're looking for the angular acceleration of the flywheel, the bigger R. Okay? Show that the torque acting on the flywheel is about 0.3 Newton meters. Torque is I times alpha. Use the correct values. For 1C, calculate the tension in the string. This tension in the string is what causes the torque. We have mg, we have the F net on the hanging mass. So you can either analyze the linear forces to determine the tension, or you know that torque is equal to F cross R, where the F is the tension in the string and the R is your choice. What do you think? Should you use the smaller radius where the string is wrapped, or the larger radius where the string isn't wrapped? Think about it. Okay? And then you're going to calculate the mass of the falling object. Hold on, sine 90 times whichever R you need to use. And then determine the mass of the falling object, analyze the linear forces, and then solve for your unknown m. Okay. Question 2 is easy. The diagram shows 2 methods of pedaling a bicycle using a force F. In method 1, the pedal is always horizontal to the ground. A student claims that method 2 is better because the pedal is always parallel to the crank arm. Explain why method 2 is more effective. So you need to think about the direction of force with respect to the moment arm, which allows for maximum applied torque. Think about your angles. And that's all. So for every one you solve correctly, you will earn 1 mark or 1 bonus point to your exam, to the next exam we take, which covers topic 2, linear mechanics, and topic B1, rotational mechanics. Oops. Thanks for watching, guys, and I hope you found this video helpful.